In this video, we're going to talk about subatomic particles, and whether you're just starting chemistry or need a refresher, this video will guide you through the core concepts in a simple and clear way. Before we zoom in on subatomic particles, let's quickly review some basics so we have a solid foundation. First, let's talk about atoms. The atomic structure is simply the structure of an atom. But what exactly is an atom? An atom is the basic building block of matter, and matter is anything that has mass and takes up space, from the air you breathe to the screen you're watching. In fact, most things are made of matter, like books, a cup, water, a dog, and people. These are all forms of matter, and matter is made up of atoms. One important thing to note about atoms is that an atom is the smallest unit of matter that still retains the properties of an element. That means atoms come in different types, and these types are what we call elements. The periodic table is a chart that organizes all known elements. For example, hydrogen is an element made of hydrogen atoms. Oxygen is another element made of oxygen atoms. The atom that makes up oxygen is different from the atom that makes up hydrogen, and that difference is what gives each element its unique properties. To recap, here's an example. You have a dog. Dogs are matter and are made of elements like carbon. Carbon is made of one specific kind of atom. The structure of that atom is called the atomic structure. Now that we know atoms are the building blocks of matter and that they make up elements, let's take a closer look inside an atom. This is what we call the atomic structure. An atom has two main parts. 1. The nucleus, which sits at the center and contains protons and neutrons. And 2. The electron cloud, where electrons move around the nucleus. These protons, neutrons, and electrons are known as subatomic particles. Protons are positively charged particles found in the nucleus. Neutrons are also found in the nucleus, but they don't have a charge. They're neutral. Electrons are negatively charged particles that move around the nucleus. Each proton has an amount of charge equal to the fundamental unit of charge, denoted as +1, and each proton has a mass of approximately 1 atomic mass unit. AMU stands for atomic mass unit. It's a tiny unit used to measure how heavy atoms and subatomic particles are. Atoms are extremely small, so using regular units like grams wouldn't make sense, so scientists created their own unit. The number of protons in an atom is called the atomic number, and it's what defines the element. For example, every carbon atom has exactly 6 protons, while every hydrogen atom has 1. Change the number of protons, and you change the element itself. Neutrons have neutral charge. You can remember that because neutron and neutral both start with the same 5 letters. Each neutron also has a mass of approximately 1 atomic mass unit, like protons. Together, protons and neutrons make up almost the entire mass of an atom. This is known as the mass number and is the sum of protons and neutrons. You can find the number of neutrons an element has by subtracting the atomic number from the atomic mass. Atoms of the same element can have different numbers of neutrons, and these variations are called isotopes. For example, carbon-12 and carbon-14 are both carbon atoms, but they differ in their number of neutrons. Electrons have a negative charge equal in magnitude to a proton, denoted as -1. However, the mass of an electron is 1/2000th of a proton, which is so small it's often negligible, or not considered. Even though electrons are tiny, they play one of the most important roles in chemistry because they determine how atoms interact and bond with each other. Electrons move around the nucleus in a space called the electron cloud. Within the electron cloud, there are regions called orbitals, where electrons can be found. Orbitals are organized into energy levels, or shells. The shells closest to the nucleus have the lowest energy, and the ones farther away have higher energy. Imagine an apartment building. The nucleus is the lobby. Each floor equals an energy level. Each apartment equals an orbital. The people, electrons, move around in their apartments, but we don't know exactly where inside. We just know they're probably there. Electrons fill these shells from lowest to highest energy, and each shell can only hold a certain number of electrons. The first shell can hold up to 2 electrons. The second shell can hold up to 8 electrons. The third shell can hold up to 18 electrons, and so on. The way these electrons are arranged, called the electron configuration, determines an element's chemical properties. The outermost shell of an atom is called the valence shell, and the electrons in that shell are known as valence electrons. These are the electrons involved in chemical bonding. Let's take oxygen, atomic number 8, as an example. It has 8 electrons. They fill up the energy levels like this. First level, 2 electrons. Second level, 6 electrons. One thing about atoms is that they want to be stable, and one of the easiest ways to become stable is to have a full outer shell of electrons. Atoms will bond with each other using their valence electrons to accomplish this. Let's look at an example. Water, H2O. A hydrogen atom has 1 valence electron, but its shell wants 2. An oxygen atom has 6 valence electrons, but its shell wants 8. So, each hydrogen needs 1 more electron. Oxygen needs 2 more electrons. When they come near each other, they can share electrons. Oxygen shares 1 electron with each hydrogen, and each hydrogen shares 1 with oxygen. This sharing allows hydrogen to feel like it has 2 electrons, oxygen to feel like it has 8 electrons. Now all the atoms are more stable, so they stay bonded together as a water molecule. Let's look at a different example. Table salt, NaCl. Sodium has 1 valence electron. Chlorine has 7 valence electrons. Instead of sharing, sodium gives its extra electron to chlorine. This makes sodium a positively charged atom known as a cation, and chlorine a negatively charged atom known as an anion. Because opposite charges attract, they stick together. I hope this helps you have a better understanding of subatomic particles. If I missed anything or you have any questions, leave them in the comments below and I'll try my best to get back to you. Thanks for watching.